so what's everyone's experience level with MongoDB? Have most people used it? Are people
who's used it?
Open to using it, like getting started with it? Most people are using it, getting started using it?
Enterprise deployment.
Enterprise deployment, yeah. Okay, cool. Ready?
Yeah, go.
All right, so I'm giving this talk on an introduction to GridFS. So first of all, who am I? I am Ben Beecher. I am a web developer at MongoDB. I think technically I'm a senior web developer, but I don't think it really matters. So in my past, I have done a lot of Python. I'm doing a lot of JavaScript right now too. I'm one of the creators of Humans vs. Zombies, which if you've gone to college in the past few years, you might have seen. I regularly hack on the Blueback asynchronous web server, which is built behind Mongo 2. If you're a Python guy, you should check it out. It's pretty neat. And of course, I work on MongoDB. And most of my work with MongoDB is limited to the Python driver. I don't actually do much with the kernels, the actual kernel of it itself. So, on to the subject at hand. GridFS. What is it? Why should you use it? What does it do for you? So, what is it? GridFS is a way to store files in your database that doesn't suck. So, I don't know how many of you have had the experience of using Postgres or MySQL or one of the more traditional databases and just sticking big blobs of binary in your database. That's a terrible experience. It's just a terrible experience. You can't do anything with it. You can't pull it out in one chunk easily. It's awful. And using GridFS, that's what you solve. You can actually store these things in your database safely, sanely, and in a way that's, a pleasure to work with. So it's also a way to keep metadata with your files. If you've ever used MySQL or Postgres and have that situation of using a big blob of binary data and come back to it a year later, you might have found yourself in a total black hole of what that data is, what it's used for, like what's its purpose in the app. There's no way to find that a lot. And that can be really dangerous because if you change it, you could break everything. Binary, you can't inspect it, you can't really do much with it. So using GridFS, you can actually make sure that there's metadata about what a file is, what it's used for, what its purpose in an app is. It's so tightly coupled to the actual file itself that you can guarantee that anytime you have access to that file, you have that metadata as well. So that's great if you want to keep a note about what something is, or you can actually hijack it and use it for your application, which is nice if you want to make sure that there's some application level data that's always associated with some files. So finally, it's also a way to get all the benefits of MongoDB, the horizontal scaling, the sharding, the replica sets. You can take that and apply it to your files. So that's really useful. If you've ever had a hard drive explode, if you've ever had a file system go down in the middle of the night, using some of the MongoDB feature set applied to files can actually be a real time saver. So how does it work? So MongoDB has a limitation in that each individual document has a maximum size of 16 megabytes. You can't put more than 16 megabytes of data in a single document. Now that's obviously a problem if you want to store something bigger than 16 megabytes. So the way we solve that is we take each file and we chunk it up into a lot of small pieces. The default size is 256K, but you can change it if you need to, although 256K is a pretty sane default. And after we chunk these little files, we stick them in the database with basically an auto-incrementing ID to tell us what order they come back out in. And that means when we want to get them, all we can do is grab the first one in that set and just sit down the line, spitting them out one at a time. When you query it and you do that one at a time, that means that when you're spitting them out, you don't need to buffer more than a single chunk's worth of data. So if you have a 2 gigabyte file and you have to pull it out of your database, you don't have to allocate 2 gigabytes of space in RAM. Only one chunk's worth. Assuming your app can push it onto. If you need to pull the whole thing into your application, then of course you need to have that much space. Nothing we can do about that. But if you use Python or some other language that has support for like a generator syntax, you can push that stuff onto the next layer pretty easily. So the way it works is after it chunks up the file into those 256 chunks, it creates 2 collections in your database. And usually they start with FS. Normally it's fs.chunks and fs.files. So that's configurable. You can have pictures.files, blog posts.files, foobar.files, whatever you need for your app. But the 2 collections, chunks and files. Chunks is where the actual data is stored. So there's 4 fields in chunks. There's ID, because every document in Mongo has to have an ID. There's files ID, and this is essentially a DB wrap for like a foreign key relation with an entry in the files collection. And this is basically telling Mongo which file this chunk belongs to. Is this picture of cat 1 or picture of cat 2? Like where does this binary data go? There's also n, which is the sequence number. If we have 30 files, that's going to be from 0 to 29. And then there's data, which is the actual binary data itself. Now, there's nothing stopping you from going and changing this stuff. It's a normal MongoDB collection. I wouldn't recommend it, though. There's no guarantee about key names, type safeness. There's no guarantee that you won't make a change that won't change how the file, the GridFS specification is for chunks. However, if you do want to put some stuff in there, we have files. So the two chunks, there's fs.chunks and fs.files. Files is where we store all of the metadata about a file. So the files that come included are ID, because again, every document has to have an ID. Now, this doesn't actually have to be a Bison object ID. Traditionally in Mongo, every document gets an object ID that's a Bison type. And we do that just to make it easier to generate it on the client and send it forward. But you don't have to do that with GridFS. So you can do anything that just is guaranteed to be unique. So some people use file names here. Some people dynamically create a path to kind of fake a path and stick that in here. Some people use a compound key for like a path and when it was uploaded. There's no hard and fast rule. The only trick with that is that you can't set this and then change it on your chunks collection later, right? Because the chunks are related to files using this thing. So some really weird stuff can happen if you change it in the future. So then there's the file name, right? Which is the actual name of the file. That's actually not required. That's actually optional. You can create something without a file name. I'm not really sure why you'd want to do that, but it's there if you want it. And there's chunk size. Again, that defaults to 256K, but you can change that up to 16 megabytes. It doesn't really make a lot of sense to change that though. With GridFS, you have the ability to pull out only specific chunks. So if you have like a huge file and you want to jump straight to the middle of it, the more you chunk that file, the more fine-grained your seeking can be. If you do a big 16 megabyte chunk, you're gonna hurt yourself if you want to jump into the middle of it because you're gonna have to go through 15 megabytes of trash before you get to the point you want. So then we also have upload date. So MongoDB creates a record of when you actually upload this file. Now we use that for some uniqueness tests and really just so we can have like a file created file timestamp, just like we use in the file system. It's really more there for your convenience as a developer than anything else. Then we have the MD5 hash. We take a hash of the data in aggregate and we populate it in the metadata collection. And we do that so that if we update this in the future, we can actually hash the file we're trying to update this with, compare the two, figure out if they're the same file or not. If they're not, we can save ourselves an operation and just not overwrite the existing data. And you can also use it as a developer to figure out whether you need to try to attempt that save or not, right? And this does give you an idea of what hash is accessible. And then we have length, which is the actual length of the data. If you store a 2 gigabyte file in GridFS, this is going to maintain 2 gigabytes, to let you know. So you should think of this as like all of the information you normally get when you type ls, right? File size, date modified, that sort of stuff. But then we can also stick in some optional extra data. And this is where things get really interesting, right? Because this is the data that we can guarantee is with our file anytime we want to use it. So if we want to be able to guarantee something like this file's been looked at 10 times, and we want to update it every time we access the file, we can actually stick that here at application level logic, which, as you can imagine, is pretty powerful. So the ones that we support with the drivers, you can add extra ones, of course, by doing it yourself. But most drivers have support for these keys natively, so they can set the content type of the file, PNG or a GIF or something. You can set that. And then we can set an alias of the file, which is useful if you want to do something where you have multiple keys pointed at the same file, like how Dropbox does it, for instance. Multiple people could try to upload the same file. Rather than duplicating it over and over, they will keep one copy and everyone has a pointer to it. This would allow you to do something like that. So then when someone reads a file, you remove it from the alias list rather than deleting the file itself. And then we have metadata, and this is just kind of a meta document that the developer gets to push some content into. Again, number of times it's been viewed, or how often people like it. Any sort of data you want there. All right, so what does the API look like? How do you actually use this in your application? All right, so PHP. Those who are using PHP. This is the code that you use to actually create a GridFS file. You create the file name, and then you just create the GridFS object using the DB getGridFS, and then you store the file using the path. And that's really it. You can pass in some extra metadata if you want. File name, here. Oh, that is included. File name. And then that procedure returns the object ID of the files item in that fs.files collection. And that's it. You store the file. It's now in your MongoDB database. So to pull it out, you do something pretty similar where you get an instance of the GridFS, and then you just call find one, which is that normal Mongo call. You normally pull one record out of the database, you call find one. In this case, they copied the syntax for that. Right? So, and then you have basically a file object. And you can just echo it out, play with it in a normal way you would. So in Python, it's a pretty similar syntax here. You open a file, and then you call grid.put, right? And that's it. That's all you need to do. And using the normal Python syntax for quarks, you can populate as many of the keys you need. Does someone have a question back there?
Yeah. Do you guys have a storage backend for Django for GridFS?
There is a GridFS storage, yeah. Somebody wrote it. I think it's included in the Mongo mapper. Okay. Not Mongo mapper, sorry. Mongo engine, yeah, Ross's one. Yeah. I haven't actually looked too thoroughly at that, which is too bad because I've done a lot of Django development. But my understanding is that it's pretty good. The actual return value, which is right here, of calling GridFS, when you do that get last version, that's actually going to return a file-like object. So it has the normal file interface read, with the one exception being that it's read-only. You can't write to it after doing that. Now you'll notice that this is get last version. So the Python driver in particular does something really neat, which is every time you write something with a similar key, it will actually version it for you if you don't actually tell it not to. So if you write something multiple times, you will actually have every copy that you've written stored in the database. And get latest version will return you the last, but as you can imagine, that's pretty helpful if you actually need some kind of versioning logic in your code. You don't have to write that, the database will handle it for you. So Ruby. Oh, sorry. Ruby slide in here. Sorry. So how do you use this in your app? So I've showed you some application logic, but obviously not everything is done in Python, or Perl, or PHP, or Ruby. So there's two good projects out here that people use. One of them is Mongo Files, which is actually distributed as part of the Mongo binary. And that's a command-line tool to put and get and delete your files from MongoDB. And the neat thing about this is you can actually use it as you would any other file source. So you can pipe to it, pipe from it, you can query it, you can run a list, pretend it's like ls, take the output, it comes out in standard out, standard error. So you can use it like you would any other file type command line. And then there's Nginx GridFS. Sorry, I keep saying Nginx. Nginx and GridFS. And that lets you actually serve media straight from a MongoDB instance without needing any sort of application sitting in between it. So as you can imagine, if you have some kind of like dynamic uploading of images, this gets really helpful. You don't have to worry about running a process in front of your static media. You just run this, you set up any rule in your Nginx conf, and every time someone needs an image, it comes straight from your MongoDB instance. So, now that I've talked about it, why should you use it? What are the features you get that will convince you to leave a standard file system for this? Because we've used and loved standard file systems ever since the Phoenix days. So what does this really give you that's better than normal file system? So it gives you archiving. It's a big one for me. So how many people here have had to write that script that goes through a Postgres table and finds every file path, and maps that file path to a file in your file system, spit that out to tar and archive that and then move that somewhere? You don't have to do that anymore with this. Yeah, it's awful, right? I hate doing that. It's a bad way to do it. But with this, you can just call MongoDB, and it's just like you would back up a normal database, right? This will be, the file binary data will be included with the rest of your database backup. Yeah?
Will that include, you were talking about multiple versions?
It will include that, yeah, because it'll include your entire database, unless you specifically version. If versioning is something you don't want in your app, you need to tell the driver that you don't want that, and then it won't keep versions. I don't know why that's the default and not keeping versions isn't, but it's easy enough to configure, so, yeah.
Not to derail too much, but how can you configure how many versions to keep? Is it just indefinite?
It's indefinite. It's indefinite. Yeah, there's no real complex logic in there, but the version number is actually stored with the metadata in the Python driver. So when you pull that files collection out, you will have a version key on it. So if you wanted to do something like that, like a round robin ring database, it would be pretty easy to set a max and just
a cat.
Exactly. Yeah, almost like a cat collection.
So as a follow-up to that,
Yep.
which of the drivers support versioning?
Well, I know Python does, and I think Ruby does, but I'm not sure about that. Because I'm a Python guy, that's the only one I really have first-hand experience with. Sorry. But I do know Python does. So it's highly available. So I don't know how many people have had a file system roll up in the middle of the night that's not rated, but that sucks. It really sucks when it happens. Now, there's nothing to stop your file systems from blowing up with Mongo, but the hope is that you use replica sets to spread it out over several nodes. If that happens, if a node fails, Mongo's internal logic will kick in, and it will elect a new master, and hopefully you'll have no downtime at all. Your files will still be served, even though you had a node go down. It has automatic failover and replication. So automatic failover is pretty similar to high availability, right? Replication is the idea that it's more durable than a fail. If a file system actually blows up, there's a fire in the data center and the system actually is destroyed. If you've spread your data over a replica set, it would be safe, even though you've lost that physical computer. Metadata, as I was saying previously, this is tied in pretty close to the implementation of the file storage itself, so you can't really do one without the other. And it's a benefit because you can really twist that and use it to your devices as an application program. So in-memory transport. So I have to be honest, this is a little slower than serving your files straight off a file system. Using Nginx with a normal file system is going to be a little faster. The one exception to this is if your working set is large enough to contain all of your media inside memory. Then you don't have to hit disk, and it's actually going to be quicker to serve your files straight out of memory than it would be to hit the disk to load them. That's not the most common use case, because most of the time you'll have more files than you will memory. But when you can get this, it's pretty powerful. So you can dynamically expand capacity, right? So MongoDB's GridFS is the only open source shared file system that can be horizontally scaled. There's a couple out there with shared file systems that are pretty good, like MongoDB, but you can't easily add new shards to it. You can't expand it on the fly like you can with GridFS. And if you run out of capacity, that can be a real problem. If you do that, though, you can just shard like you would a normal MongoDB collection and you have more capacity. Versioning, as I previously stated, you get versioning for free, which is, I think, a benefit. And I think that's it. That's it. Is there any questions? Sorry. Yeah?
Yeah, first question. Back to your example usage. I think you said I get a database reference and then I call GridFS on something on that.
Yeah, let me pull back to it. Do you mind if we use the Python one?
Yes. So I'm taking a connection. So I'm getting a particular database.
You're getting a particular database.
Do you recommend that you have a separate database for your files and for your...
No, absolutely not. What you do end up getting is a separate collection within your database, and you can actually give that collection whatever name you want, right? So you should treat this collection as essentially another place to store binary data, right? If you have a specific kind of binary data that you want to store, like photos or user avatars or anything, my recommendation would be to make a specific GridFS collection for that one item, and to treat them more like database tables, right, where you only store one kind of data. There's nothing to stop you from mixing and matching multiple files, but to me it makes more sense to structure it and actually keep like files together. Then it kind of also has the benefit of acting like a path a little bit. There's no paths in this, right? So you have to have some way to like store what kind of file is with the data, other than the file name. If you have like multiple JPEGs or something, right? And that's a nice way to do it. That's a nice way to like mark what kind of data you have.
How does, I'm going to ask a question about sharding. I'm assuming that when you shard with this, it's going to put all of the data for a single file on a single server. It's not going to spread it out?
That's exactly correct. You must use the file ID. That's the shard key. You must use that. Because you can't actually get into a situation where you've sharded the data from a single file over multiple systems. It's a limitation, and I think they're working on fixing that.
So it could actually spread the chunks to different servers?
Well, there's nothing, right now you can't because the it's just not expecting that. There's nothing theoretical to stop you from doing that. Right now that is a limitation. You have to ensure that the data for a single file is on a single shard. And that's why you must use the file ID as a shard key if you end up sharding your data. Yeah?
Something interesting said about the chunk size was going smaller allows you to obviously seek to different points.
Right.
So why not make the default smaller than G56?
I don't know.
And is there any performance drawback, I/O drawback, of making smaller chunk sizes?
I mean, you're going to make a lot more collections. You know, if you store 2 gigabytes of data, you could theoretically hit a collection count, right? There is a maximum, however high it is, and if you end up storing a lot of data, you could not follow that. There's no really reason not to. I mean, I don't know. It's 256K is a nice round.
I think it's a performance issue. I think if you decrease the chunk size, you're going to be looking up those chunks more frequently.
Right. Well, that's true. You'll have to make more queries, and you'll have to look through more.
There's some really good, really interesting papers written on chunk sizes and stuff.
If you're doing RAID, you probably want to match your chunk with your start size too.
Sorry?
If you're doing RAID, you probably want to match your start size.
That would be ideal, right? And then you can guarantee that each chunk sits in a specific. Yeah.
So the MD5 hash, that's on the metadata? And not the
That's
chunk?
included with the metadata, yeah.
Why is it not on a chunk? Because it seems like in case of a large file, if you got bit rot, you have to do the whole file.
Yeah, you would actually. If you have any bit rot at all, you have to throw away the file and start again, right? That is a problem. The idea though is that because you're using a replica set, if you have bit rot on a single of the nodes, the fact that there's 2 more that are keeping the variant copy would
But if you had it on a chunk, it's even more efficient to keep a chunk.
well, but then you have to keep it in every chunk rather than just once, I guess. I don't know. It's not really used as like a guarantee that the data is stable. It's really mostly used by the driver to ensure that they don't have to waste writes. It's not really used as like a data validation tool. Yeah.
Can metadata contain ACLs?
Sorry.
The metadata, can it contain ACLs?
There's nothing to stop you from putting anything you want in there. Yeah, I mean it's just a normal MongoDB document, so you can put any kind of data that you could normally put in MongoDB. If you wanted to use it for a provisioning system, you could. You'd have to roll your own logic around that, of course, but if you wanted to keep the actual permission bits in there, nothing to stop you from doing that. Yeah, I've actually, when I've used this in my projects, I've actually pulled in the Unix permissions and just used it that way, and then check the ID of the user when I use it. Yeah.
Is there a max file size for this, or?
No, there's not a max file size. Because it's split over multiple chunks, there's nothing stopping. I mean, yes, there is a max file size, which is as much data as the Mongo collection can hold.
Okay, so the size is
Yeah.
a big one.
Yeah, it's big enough, right?
Sharding the limitation on the file size.
That would be a limitation of process, that's true. If you had a file big enough to require to be sharded for the servers, you'd be in trouble.
The versions for Mongo, is there an easy way to interrogate, find out the differences between 2 versions?
There's not, unfortunately, there's not. The GridFS doesn't provide a really good tool to look at like diffs in any way. And in fact, it doesn't really support much of editing a file in place. If you're going to change a file, you really need to just upload a new version. Yeah.
Is GridFS standalone, or is it something you get when you install Mongo?
It is. It's a part of MongoDB. It's really a specific use case of MongoDB logic that's just exposed to the drivers in a fixed way. There's nothing really at the heart of it different about GridFS than a normal Mongo collection. It's just that you're writing to it in a specific way, and you're writing a specific kind of data in it. Yeah.
And so it is available from all 10-gen drivers.
Yeah.
Although various implementations of what's supported.
Yeah, absolutely. To my knowledge, every driver supports it.
Okay.
One last question. I know you can have full text search in Mongo. Can you search across text in these chunks? Because a chunk may contain part of the text you're looking for, and a different chunk may contain.
I see what you're saying. I don't think there's a good way to do that using MongoDB straight. You could maybe do some kind of query, but there's nothing to tell you like where that text can be split. Like there's no way to say like half the text on one chunk and like half the text on another. But remember, it's binary data, so generally speaking, if you have just some raw text, you should probably stick that not in a GridFS, but just in a normal collection.
At least for my use case, sometimes we store binary file formats.
Right, and you want to like use strings or something to pull the content out. Yeah, there's not a good way to do that using this if the strings are broken. If they're on a single chunk, then you could do that. But your best bet is to pull the chunk and pull the file from memory and search it using your application.